decision making. And our problem is, should Flint switch to bottled water? So a mean lead level of 15 parts per billion is considered safe, while anything above 15 parts per billion is considered dangerous. Miss Anderson believes the Flint water is unsafe, so she takes a random sample of 200 households. She finds the average lead level of the sample to be 16.5 points per billion. So first, what we're going to do is we're going to identify our population, parameter, sample, and statistic. So our population is going to be all the households in Flint, or we could say all the Flint households. Our sample, all right, as it says up there, is 200 that were randomly selected. Our parameter, we're going to use mu to show our true mean lead level. And lastly, our statistic is what we got from that sample, which was 16.5 ppb, or parts per billion. So now what we're going to do is we're going to state an appropriate hypothesis for performing a significance test. So our null hypothesis is that everything is safe, so that our true mean level is at 15. All right, and you can make a little note here that the water is safe. For our alternative, all right, if it is greater than 15, that means that the water is unsafe. All right, so Miss Anderson simulated taking 100 samples from safe water, assuming that our null is true. And from the dot plot, estimate the p-value for 16.5 parts per billion. Well, we know that this is 100 dots, right? And so let's see how many dots are above 16.5. So we have 3. So that's 3 out of 100. Which would get us a p-value of 0.03. All right? So basically what this means is that assuming that our null is true, so H of O is true, you know, the water being safe, say safe water. We're going to say there is a 0.03 probability of getting a sample mean of, and now remember our sample mean was 16.5. Or higher, purely by chance. All right. So based on this p-value, should Flint keep the current water or switch to bottled water? All right, what do you guys think? Do we think the water is safe or not? Well, our current p-value, you know, our sample mean is greater, right? Like we don't want to give people lead water. So I'd say the water is unsafe. and that we should switch to bottled water. Now, let's suppose this decision is wrong. All right. What would be a consequence of this? Well, if we're switching to bottled, when our water was really safe to drink, it's going to cost our people money. All right. That would be a consequence. So we could say, it will cost the residents more money. All right, so now suppose that the p-value is 0.14. So should Flint keep the current water or switch to the bottled water? All right. Well, if our probability value is now higher, we're going to say that the water is safe. And then we don't switch to bottled water. So now we suppose that this decision is wrong. Okay? So if this decision was wrong, what would be a consequence of our error? Well, if we're telling people the bottled water is safe, when it's not, people might get sick, right? So we could say people might get sick from drinking, the lead water. Is the error made in question 5 or 7 more serious? Well, in question 5, we're just going to be spending more money. While in question 8, people can die. So I think it's worse, hopefully you guys too, think it's worse that, people's, lives are at stake. So we wouldn't want to make that error. All right. So I think we'll say that in number 7, because people's lives are at stake. You wouldn't want to be the mayor making that wrong decision. All right, you guys. So that is the end of this activity.